Today we're going to have a brief discussion of the history of Genesee's water system. This is in response to the water crisis, essentially, that the town of Genesee, Idaho, has had for the last few months, when the town has done really an admirable job in water conservation to help solve the crisis. We start off with a little bit of geology. The brown area here shows the area that is covered by the Columbia River basalts. These are a thick series of basalt flows that issued out of fissures along the what is now the Idaho, Oregon, and Washington border. You can see the green dikes that are shown up here. And it occurred over a period from starting about 17 million years ago to 5 million years ago. We're on the very edge of it in Idaho, where the basalt flowed in and out around existing terrain. As you go out further to the west, the basalt flows get thicker and thicker to where when you're in the Tri-Cities area, you're over 10,000 feet thick of all these basalts. This is Steptoe Butte, which is a very old rock that sticks up above the relatively flat layers of Columbia River basalt, which flowed into this area, flowed in and around Steptoe Butte, filling up all the valleys and so on around it as time went on, but leaving the butte exposed to the surface. And you can see in this diagram to the right here, the Columbia River basalt flowed in and out around the topography. It could have possibly have covered hills, but in those places the basalt is thinner than it is where there were old drainages and so on, confusing the issue as to where exactly you might drill to find water in here. Sitting on top of the basalts is what we call loess, L-O-E-S-S, and that is a glacial dust from the last glacial period that blew into this area after the glaciers were gone, and what helps make the wonderful Palouse soils that are so important to our agricultural livelihood today. If we take a look at the geologic map of Latah County, you can see Genesee down at the bottom down there, and above it an inch or so is Moscow. The purple unit labeled TCR that surrounds Genesee is, of course, Columbia River basalt. And almost everything else in the county are older rocks. For example, Moscow Mountain is KGD, which is granite. So you can imagine all these rocks, and of course they're all eroding in between times that these Columbia River basalts have are outflowing. A good example of how thick these basalts can be is if you go from Lewiston and you go up the Snake River a ways, you see 1,000 feet or so of Grand Ronde basalt, and you can easily see the individual layers of basalt that came out flow after flow after flow. And if you trace these over into the area near Tri-Cities in Washington, you find that there's over 10,000 feet of basalt in that area. So we are relatively thin here along the border zone on the east side. Now, those individual basalt flows are of interest to us because they have different parts within them. Since the basalt is about 1200 degrees centigrade plus when it comes out of these fractures, and it flows sort of like water, although it's a little thicker than that. The bottom part of the basalt, as soon as it impacts the old terrain, it cools very rapidly into a black glass, which forms the base of the flow. Later, when the flow is stopped, the upper part of it, which is very hot, is exposed to the air, and it also will cool very rapidly, giving us a gassy-filled, glassy top to the flow. And in between those, the top and the bottom, are layers of thick basalt, which in places may have beautiful columns in them, 5 or 6 sided columns, or they may be just more or less hackly, dense, broken up interior material like you see down here. Several different types of things that you can have in these individual flows. Parts of these flows, of course, where you've got lots of fractures in them, are much more amenable to water flowing through them than the other parts. For example, the black glassy part pretty much forms an aquiclude, as it's called, which stops the water from flowing up or down within the basalt flows. The basalts have all been divided out by geologists into various formations. For example, Saddle Mountains, Wanapum, Grand Ronde. The only ones we're going to even be concerned about is the Wanapum basalt and the Grand Ronde basalt. And in Genesee, we have the Priest Rapids member of the Wanapum basalt. We have a little bit of the Asotan member of the Saddle Mountains basalt, just south of town here. And if you drill a hole deep enough for looking for water, you will get into the Grand Ronde basalt, the top of it up here, which is about as deep as we've gone. The N2, R2 here are the polarity within these basalts. That's one of the ways geologists can tell where they are in these thick columns of basalt after basalt after basalt. The north and south magnetic poles occasionally in geologic time flip back and forth, and we can measure that in the field. We can also, of course, take a look at the chemistry, which we have lots and lots of data on now for these basalt flows, and many of them have a fairly distinctive chemical signature. This is a longitudinal section. It extends from Moscow over into the Pullman area. And the bottom line here shows you all of the water wells that were used to construct this cross section. And you'll note that when you're over in the Moscow area, you get lots of yellow material intermixed with the basalts. And the yellow material are sediments that have eroded off of those highlands, like Moscow Mountain and Steptoe Butte, that fill in on top of the pre-existing flows, and then they may be covered up by the next flow that comes in, and so on. So it's a layer of sediments generally referred to as the Latah Formation. And one part of that Latah Formation is called the vantage member of the Latah Formation. And the vantage member more or less separates the Wanapum basalt from the Grand Ronde basalt. So it gives us a signature when we're drilling holes, another way of telling where we are kind of in this great big stack of basalts. Now, the geologic map that was done by John Bush and others in 2001 of Genesee is pretty simple. We'll look at this in a little more detail here, but you'll notice the top part here is pretty much all kind of a reddish color. That is a unit within the Wanapum basalt. And the kind of little more purplish color down here is the Saddle Mountains basalt, which occurs just south of town. So if you're standing in town and you look off to the south, you'll see the layers of Saddle Mountain basalt going up above it. The yellow is alluvium that is in the drainage of Cow Creek. And alluvium is loose gravels and sands and other debris. They're formed by the erosion of Cow Creek over time as it has moved back and forth across its floodplain. Also, it is in many places very permeable, and you can get a lot of water that moves through that alluvium, and we'll see that could be a problem for us. Now, I say there's no faults, and faults are fractures in the rock where rocks are offset against one another. It's very difficult to see these in the basalts because it's black layers of rocks against black layers of rocks. And you'll note that John chose not to put any faults essentially on his map. Other geologists would tend to put more faults on than John might have done. It's not right or wrong, it's just an interpretation as to how you want to go. I happen to believe that there probably are more faults in the basalts here than we would be led to believe by the map. Now, if we take a closer up look at that, we can see we're in the Priest Rapids member of the Wanapum up here at the top, the Asotan member of the Saddle Mountains basalt down below, and the alluvium in the middle here. Genesee drilled wells 1, 2, 3, and 7, right where that blue arrow is, which is right on the contact between the wampum basalt and the alluvium. And this can cause a problem because water in the alluvium is near surface water, so all the fields that are draining into this area or anything else draining into this area will fill these gravels within the alluvium at various times, especially years that you have very high water. That water then could interact with water that is in the aquifer or the water-bearing zone of the wampum in which these wells all are drilled. And if you have contamination in the younger water within the alluvium, then you're going to get contamination within your wells that sit right there on the contact. And that is quite likely a possibility as to what is going on with our problem, especially with well number 3, which is one of our major producing wells in Genesee. This is the cross section that John drew pretty much north-south through Genesee on his geologic map. It shows, it looks pretty similar to the long section that we had going from Moscow over to Pullman, the layers of basalt separated in a few places by the Vantage Formation between the Grand Ronde and the Wampum. On the top, we've got alluvium from that's the recent sediments like we would see along Cow Creek. And we have the Plouffe Formation, which is the glacial dust that we described that sits on the top of everything that makes up the actual soil that we're growing our crops in. This is a thesis that was done by Bill Lawrence at the U of I in 1995. It's an excellent piece of work. He did a lot of review of well logs in our area. Every well that is drilled has to have a log done on it by law, which tells you where you are within the section. And this particular figure is very interesting to me because he shows our wells, 5, 2, 5, all the wells across here. He shows the producing zones. This is the area where water would be concentrated in, which when you pump it, that's where the water comes out of. And he's interpreted then where the Vantage interbed, which we said separates out those younger wampum basalts from the older Grand Ronde basalts, might lie. If that's true, then this actually gives you a fairly good guide as to how deep your wells are. And you can see there's not a huge difference in feet across where that line is. So he's got that laid out as that our water level is the Vantage is at a very tight horizon across our area. Now, finding faults, as we said, with Genesee is very difficult, and I don't mean that as a joke. We're talking about geologic faults, of course. Here's our sewage lagoon out on the south of town, the east end elevators, west end elevators. But the rest of the country is fairly flat out here. It gets a little more hilly as you get closer to that contact zone with these older rocks. And so it's difficult to see structures that are within these types of basalts. Well, one way that we might want to do it is we should take a look at LiDAR imagery over Genesee. And LiDAR is it's called light detection and ranging. It's like an aerial photograph, except the airplane flies over. It shoots down a laser beam, which then bounces back to a receiver in the plane, and we can very tightly measure the time that it takes to do that, which gives us an indication of topography or the height of the land. And it does it ignoring vegetation that is in the area. That's why this looks kind of weird here. Here's Genesee sitting here. There's no wheat or anything in our fields. Unfortunately, because of the subdued topography, you would need a larger section of LiDAR imagery, which may or may not be available or be useful to us to take a look at. And this is what that one particular frame of the whole area would look like over Genesee. Again, one would be tempted to say there might be some sort of a structure going through this section of Genesee, but we need more imagery around it in order to make that call. And even then, you're not saying it's a fault. It could be just what geologists call a linear, or a straight line in the topography, which is there for some reason or other. Now, when we take a look at the Moscow-Pullman area, they've done a lot of work and record keeping over many years as to what is happening in the aquifers in their area. And there's two of them, as Pullman is in the Grand Ronde, or the deeper aquifer, and Moscow is in both the Grand Ronde, the deeper aquifer, and the Wanapum, which is the same level that we would be in Genesee. We do not know if the Grand Ronde aquifer is in the Genesee area, and we've never drilled a well deep enough to find out. The problem with the Wanapum with the Grand Ronde is it's decreasing over the years, about a foot a year, a little less now, a little more earlier on. They've done a lot of water conservation measures in both Moscow and Pullman, which have been very effective in slowing this down. But it's still going down, as you can see. So there's concern about what will happen someday. They're going to run out of water in that Grand Ronde aquifer. And this may be fossil water, 10 to 15,000 year old water that is not being recharged. In other words, it's very pure, probably glacial water that's been sitting down there for a long, long time. Wonderful water. You couldn't get any better water. But once it's gone, it's gone. So both the communities in Pullman and Moscow are looking at alternative ways that they may be able to provide a water source. And this would include surface storage, i.e. a reservoir that they may want to build someplace. It'd be very useful for Genesee to keep track of what is going on with PBAG. Now, that's what the Wanapum, the Grand Ronde aquifer looks like. This is what the well logs from the Wanapum, which is the one that we're in, look like. And they're up and down all over the place because they have annual recharge. They're relatively shallow, so when we get a spring thaw and the water fills up all the drainages, that water is able to get into the upper aquifer and recharge it. The advantage is, well, it's rechargeable, so you get new water every year. The disadvantage, if you get contamination in that water someplace, you can run into problems with it, and it generally is not as pristine a water as you certainly would get out of something like the Grand Ronde or the deeper aquifer. Here's a well log. It's a little difficult to see, but when you look at it, you can see this well was drilled to 825 feet. It's test well number 2 in Genesee, which is on the west side up by the storage tank up there. It was drilled in 1993. They were going to try to get into the Grand Ronde aquifer. They got down 825 feet. They were in the Grand Ronde, but they didn't find any water, and it's quite likely they didn't go quite deep enough within the Grand Ronde to find it. But that's down 825 feet, so your pumping costs and everything become much higher. At that particular depth, when they quit, they were hit about 25 gallons of water per minute. Now, even though we lay out these nice, straightforward-looking layers of basalt, which look like they go on forever, that's obviously not the case. And your chance of drilling a well and hitting water is good, but it's certainly not guaranteed. And here, for example, is a well that was drilled on the Lindquist farm just south of town here. They went 445 feet in basalt all the way, and they didn't find any water. So it's no guarantee that you're going to find it, even with the science that we've got behind us to help us, guide us, if you will. Well, let's get to Genesee. Genesee, of course, forms in the late 1870s in Old Town, which is a mile east of where we are right now. But in 1888, the Northern Pacific Railroad arrives in town, and we start New Genesee, where we are right now. And this is our first map of Genesee in 1891, just a couple of years after it actually was founded, or Newtown anyway. And it's a Sanborn fire map, and that these maps were done for fire insurance purposes, so they were very interested in where any water was. And we point out here the town got its water from shallow, usually hand-dug wells, many of them. A problem with this was that there was no septic system within the community or sewage system at the time, so everybody had outhouses, and there was no requirement, as there is now, of a fairly long standoff between where you may have sewage and where you may have wells, certainly within community systems like we have in Genesee and other towns and communities. So we were stuck with individual water wells, and very early on population began to grow. We started with zip, and we would go up to 800 people within a very, very short period of time. As you can imagine what this town must have smelled like in August when we had dirt streets with all the animals that were bringing. That's the only way we could get to town, of course, was they had horses that brought things into town. You had that, plus you had the outhouses. Not a good situation, and definitely not a good situation for your water supply. Another major problem as we grew population was fire control. And a good example is the Methodist Church in the center here, which burned in 1914. We had a city water system by then, started in 1904, but there was a heavy wind blowing that day, and there was great concern that the church, the fire from that church, was going to take out the whole town, as these fires had done in many other communities around us. But Genesee lucked out. They dynamited a building or two, which is a way to keep the fire from spreading at the time, and they were able to save the rest of the town. It was noted we built the first domestic water supply in town in 1904. With 2 wells, well 1 and 2 downtown, with a storage reservoir up on the north end of Laurel, and that addressed pretty much the domestic supply that we needed at the time. We also put some fire hydrants in around town, and the way that it would work is if there was a fire, there were 2 hose carts, one on the east end of town, one on the west end of town, and whoever was the first guy that got word on the fire, he'd race down, he'd ring this bell, and they could get the hose cart out and take it up, hook it up to the closest hydrant, and that was the firefighting tools that they had at the time, and really a very early version of the volunteer fire department. The brick building that you see just to the left of the hose cart building is the Conant building, and that was on the northeast corner of present-day City Park. None of these buildings that are in the picture here are left. So if you're not familiar with the history, you're just walking by the parts of City Park today. Well, this is what the pump house looked like. It's the same pump house we have today, where wells number 1 and 2 were drilled in 1904. And I show you, right, fire hydrants were important because there's one sitting right there. There's the Conant building that we mentioned earlier. Now, when they tested their first water system out, they found that many of the earlier water pipes that had gone from individual wells to buildings leaked. And not only did they leak, they were made out of wood, wrapped with wire, and they all had to be repaired. The new pipes that were put in were all made out of cast iron. And when you look at the consultant's report as to what we're going to have to spend some money on in Genesee, one of the things is replacing a significant amount of cast iron pipe, much of which has probably been there since 1904. So it's pretty much gone. It's leaking. It's rusted out, if you will. Is a major concern. Probably second to our well issue is the issue that we have with our distribution system within a community. Now, since the community was running on wells 1 and 2, there was some concern that if they ever lost electric power to power those pumps, there could be a catastrophe within the town. So in 1952, the city bought a Ford V8 industrial engine, flathead engine, to provide generator power for those two pumps. And actually it was used once or twice, but they ended up with very few hours on the engine. And so in 2005, the city sold the V8 engine to Marlin Callahan. And you may see Marlin's 1938 beautiful Ford pickup driving around town, and it has the flathead engine in it, although slightly modified, from our first wells at number 1 and number 2. Not terribly significant for the water history, but an interesting little sidelight. This map, again taken from Lawrence's thesis, shows where all of our wells are within the community that we have now, and I've added in the dates that they were drilled. And you can see they concentrate on essentially in 3 major time periods or areas. This is the old pump house with wells 1, 2, and then next to it is number 3, and then well number 7, which was drilled as an experimental well a number of years ago, had pretty good yield in it for a while. But it had contamination problems. And all of these wells, that's our problem, is we have contamination problems in them. To the north of us, reservoir number 1 was first installed in 1904 and then was replaced with a new tank reservoir that we have in 2010. And in 1994, we drilled a well up here, number 6, which we had hoped was going to be able to help us out in our current situation. If we could have pumped water out of there and mixed it with water from well number 3, which is down here, we could have diluted the problems with our nitrates, which is the main contaminant we're worried about right now. In 1904, we also put in a concrete 250,000 gallon reservoir up at the top of the hill, which was replaced in 2010. Now in 1980, they really got behind the game here, and we put in a whole new water system on the west end of town, including well number 5, which is our only producing well right now that we're using, and reservoir number 2, which is the blue tank over on the west side. We also drilled 2 test wells at the time, test well number 2 and test well number 1, neither of which would produce enough water for us to do what we needed to do. Well number 4 is called the Ludke well. It's the one out by the city cemetery. It was put in the 1940s actually to provide a little more water for the east end of the area, primarily the PNW's East End Elevator Complex out there, as well as provide water for the city cemetery. Now, if we take a look at all the dates when these wells were drilled, they tie very closely to major changes in population within the community. And we're not going to go into this in any great detail, but simply just to remember that when we had a huge increase in population, like we did from 1890 up to 1910, we all of a sudden needed a big water system. And that's what happened. Then we go into a period of declining population. Look at from 1930s to the 50s and so on. It goes down and down. Not too much interest in doing much in there until we start to get a bounce in the late 1960s, and that's when we drill well number 3 down by the old pump house down there, and so on and so forth. And now you can see we're in a period of really pretty rapid growth, and the loss of a well due to contamination. We definitely need to do something to increase our water supply within the community. Again, an image showing well number 3 sits down at the area, the one that was drilled in 1963, and was a major source of water for us up until the beginning of this year. And we'll see, it really wasn't the beginning of this year. We've known for some time that we were going to have to do something about those wells that sit down there right on the convergence of the floodplain of Cow Creek and the Wanapumpa Salt. This is the inside of it, just for historical purpose. The inside of the well house, if you've never seen it, with one of the old pumps that was installed in the area. Both pumps, both wells 1 and 2, were removed and plugged in 2018, and the building's now empty, and it's being taken over by the Civic Association for storage facility. The pump house as it looks, we can see the well number 3 sits in this little building over here on the left-hand side, and the old pump house pretty much as it looked like in 1904. It's been decorated here a little bit with some murals and so on that were done a few years ago. Now, the original reservoir that was built in 1904 was sat up on top of the hill. After it sat up there for a couple of years, they put a covering over the top of it. And many of you remember that. Actually, if you went inside and took a look at it, you could see how old it was, because we've actually got round logs up in here that were used to support the roof when they finally went ahead and put it on. A very old structure, and definitely not the best resource that you would have for water storage today. And this was the one that was replaced with our new reservoir number 1, a much more modern system, in 2010. And as we mentioned, in the 1980s, we had our big building thing over on the west side. We put in well number 5, which is shown on the right here, and the storage tank for that tank, well over on the other side. A terrible slide, designed more for the historical future, so people can see when things happened within our wells. And we don't try to read any of this, but we just point out that back in 1976, we started getting high nitrate levels recorded in wells number 1 and number 3. And my guess is this was before there were really any requirements on nitrate contents in drinking water. It was probably early in the game. They probably hadn't been analyzing for nitrate for very long within the well. In 1992, EPA came out with a regulation for nitrates within the water, which is 10 micrograms per liter, or 10 parts per million. And that's the one that well 3 is always tinkering around with during certain parts of the year that are causing us our problem. And as we see, nitrates continue to be the problem. It hasn't been the only problem we've had. We had what was called PERC, which is a tetrachloroethylene organic compound in wells number 1 and 3 in the 1991. Fortunately, it went away. It probably was from water contaminated by PERC from a dry cleaning establishment, which was in the old Conant building, again across from City Hall, where City Hall is today. And we've occasionally had issues with bacteria within the water. This is typical of most small community water systems. You get a little contamination in them. Sometimes you fix it, and other times it goes away on its own. In this particular case, in 1996, we had to go to a boil water system within the community for a while due to coliform bacteria within our system. This is the Conant building, as we mentioned, where the dry cleaning establishment was, and which is probably the source of a PERC plume that was below the business. It was built in 1905, just after the water system was put in and torn down about 1957. This shows what's happened in the 20s. Again, all of it now is high nitrates. It brings us into 2018, when it was bad enough that the city actually issued bottled potable water. I remember seeing the gallon jugs of water sitting down on the steps of City Hall that you could pick up for drinking and so on. And takes us to 2020, which is our nitrate problem that we have. Now, the nitrate issue is kind of an interesting one. It's one of those sideline things that comes into effect in farm country like we live in here. This is a picture of wheat fields in the early 1900s. It was called Russian wheat was one variety. There were several of them, but they all had these very long stems. The gentleman on the right-hand picture is 6 foot tall and very small heads. So all the energy of the plant was going into growing the stems. If you got wind that came through these fields, obviously it would just raise havoc with the production of the wheat in the area, which was, of course, very small compared to what we have now. If you got 30 bushels to the acre back then, you were doing pretty good. Now, 100 bushels to the acre is certainly not the exception to the rule. And this is what, of course, it looks like today. The background of Genesee, the background of the world's food supply sits right here on these short-stemmed new varieties of wheat. And they came about over concern about world population growth in the 1940s and 50s. They were projecting out that's the green line right here, what it was going to look like. And with the food production that we had in the world at the time, it was believed that we would go into, within a very short period of time, huge problems with famines. There was no way we could feed the world population with the cereal grain production that we were able to get at the time. And so research started. The solution to the problem, of course, was quite simple. Grow more food or higher yielding food. Obviously much easier said than done at the time. This is one gentleman, Norman Borlaug, who was awarded the Nobel Peace Prize in 1970 for the development of several varieties of short-stemmed wheat and other cereal products that were a key element in what is now known as the Green Revolution, which started in the 1960s and spread into developing countries very quickly. Actually, most of his work was done in Mexico. The state of Iowa had a statue of Borlaug placed in the Statuary Hall in the United States Capitol. So a very famous man, and followed by many others. For example, Washington State University and University of Idaho today have large research projects and programs underway to continue right along with what Borlaug had started. There is a downside to this, of course. You needed more water and more fertilizer to make these short-stemmed, more hardy plants grow. And today, with the amount of fertilizer that we put on our fields, although it is becoming less and less at all times, as we develop new varieties of wheat which require less fertilizer, but that is a possible source, certainly, of the nitrate problems that we have within our wells. And if the cost is drilling a new well, so be it. Well worth it compared to the food production that we enjoy today and the economic well-being of our community. Well, that brings us to an end of our relatively short history of the development of water in our city. We certainly would encourage you to continue to go to the City Council and other town hall meetings in person or via Zoom. Our water bond is on the November ballot coming up here in just a few weeks, which we would certainly ask you to please vote on everything, as well as the water bond. The bond is a spending authority bond. It is not for $3.5 million to be spent all at once. It gives the City Council the opportunity over the incoming years to spend that money as is required to make sure that we continue to have a good water source within our community. And of course, finally, last but certainly not least, we all want to conserve water wherever we can. So with that, I'd like to thank you for coming to listen to this presentation today. My name is Earl Bennett. I'm the Genesee City Historian. And you can get a hold of me. My contact information down here, easiest is my email, which is Bennett, B-E-N-N-E-T-T, @uidaho.edu. Hope you've enjoyed the presentation. And remember, conserve water. Thank you very much. Good evening, and enjoy the rest of the presentations.